on to my presentation. To begin, I'll be providing some background information on the company that has provided my dataset, Yelp, and why this analysis is relevant to their business. Then we will dive into the dataset itself to understand its structure and how it will be prepared for analysis. Following that will be a discussion of the data analysis methods to be used, including both data mining techniques and machine learning algorithms. Lastly, we will examine the lessons learned so far about this data, as well as lessons learned in the analysis. It is always important before beginning any analysis to understand the industry that you plan to examine. Companies are always seeking a competitive edge over their competition, and public opinion is an important measure. Market research, as an industry, generates $44.35 billion in revenue globally, with U.S. firms commanding half of the global market. From 2009, this market has consistently grown year over year. One of the biggest opportunities available for a company to gain insight into their customer is through social media. There is a large amount of data being generated each day across all social media sites. While social media sites like Facebook, Twitter, and Instagram can capture general sentiment, there are other social sites whose data can be used to assess a company's quality. Yelp, which was founded in 2004 to address this customer need. This social site uses crowdsourcing to gather information on businesses across the globe. And for the benefit of this presentation and for this assignment, the company that I represent has been contracted to assist in evaluating the accuracy of Yelp's user-provided reviews, as well as some enhancements that we'll get into later. To meet this stated goal, I, the analyst, will utilize the words written within the Yelp reviews and their tip dataset to determine if the review scores. So what exactly is Yelp Incorporated? As I mentioned in the previous slide, they were founded in 2004, and since then Yelp has become one of the most trusted resources for information on local businesses. With over 135 million user reviews, it is by far one of the largest repositories of customer sentiment. Yelp meets the needs of both companies and their patrons. For patrons, they offer a one-stop shop for finding information about local businesses. However, beyond the standard information that can be found through a simple web search, things like hours of operation, address, contact info, users can learn what Yelp's unique community thinks about a business. Yelp users come in different flavors. First, there's the standard Yelper, who simply leaves reviews. The next reviewer type, however, is the elite Yelper. These users are nominated by the community as someone whose reviews can be trusted. These users' reviews will show up above other users. These reviews also tend to be longer, with more detail as well as images and other multimedia objects. For companies, on the other hand, Yelp offers a unique advertising opportunity. Companies always want to get in front of customers, so the idea of getting in front of Yelp's 100 million plus unique visitors per month has to be intriguing. Companies also can, of course, list themselves within the site, which is how their information gets on Yelp anyway. This gives them admin privileges over the items that are posted to their businesses, both good and bad. They also have the ability to purchase ads on Yelp that will ensure that they come up in front of potential buyers. What businesses need to grow, thrive, and increase their market share varies from company to company, but some things remain the same. As it with any web presence, you want to increase your user engagement, and in Yelp's case, in the form of user submissions. You want more and more users to come onto the site, spend time posting user reviews. So to do this, your user review submission process should be simple and can be streamlined. Gaining new businesses and increasing the engagement of those businesses is important as well. To facilitate this, companies need to understand what users are saying about their business and see a return on their advertising investment. Again, more users in means more people that see your business. They can get in front of your customers or get in front of these companies, go out, write more user reviews, which brings more people in to each and every business. So how does Yelp get that information up in front of the user? Yelp has developed an internal user recommendation engine that bubbles up information to users. It takes into account several different factors, but primarily it is driven by the number of reviews a company has, the average review score, as well as the quality of the reviews that have been placed on it. Outside of ad buys, this helps companies to show up in searches for users. The analysis that we're going to be doing in this project is going to help enhance that recommendation engine by going beyond just your standard, okay, does this review have a high score? So let's show that to a customer. But actually taking the text of the reviews and adding that into a company's rating, thus increasing the variables that can go into this machine learning engine for recommendation. So now it's time to take a look at the data. Every year, Yelp holds a data analysis challenge, with the goal being to utilize their data in innovative ways and to break new ground in research. As of 2017, hundreds of academic papers have been written using their dataset. While it is not an exhaustive look into what Yelp captures for every business user and company, it is a good look into what data they are capturing and how it is structured. And it provides a lot of data that can be used in a variety of different ways for data analysis. The dataset itself holds information on 156,000 businesses across 12 geographical areas. There are more than 4 million reviews, and the non-graphical portion of the dataset is close to 6 gigabytes uncompressed. So with that being said, of course I will be sampling this data, but we'll get into that when we reach the lessons learned part. Yelp gives you two ways to download the data for the challenge. The first being structured query language scripts, which will build database tables in a relational database like SQL Server or Oracle or MySQL. Also, you can download it as a series of 6 JavaScript object notation or JSON files. For my analysis, I'll be working with the JSON files and not SQL Server. And the file that I'm going to be working with is the file that houses the user reviews, at least for the benefit of this presentation. Inside that data set or inside that file, there are 4,736,897 records, and each one of the records has 9 variables. The snippet that you see on the screen shows how each review record is structured. The main attributes that we will look at in our analysis are the fields that are the field text, which of course is self-explanatory. It's the text of the review. We will be also looking at the star rating, the review ID, and the business ID, at least initially. The fields that are there marked useful, funny, and cool. While they are interesting bits of data, they're not going to be relevant to the type of analysis that I'm doing in this case. But it might be something that we could go back to or could use for some other type of analysis. If you look at this, the text of the review is truncated, and I just did that for space so that this could be big enough so you could read it. But trust me, these reviews are, in many cases, multiple paragraphs long. For the benefit of this presentation, and probably for most of my project, I will just be using R and RStudio. I find R to be very simple and straightforward for me to utilize. It does a lot of the work that I need, and I've gotten pretty proficient in working with it. I'll be using several packages within R that were created for text extraction, sentiment analysis, data mining, and data visualization. The packages that I have used so far while working on this project are the reader package, which is what we're using just to read files, the dplyr package, which is I use to convert the flattened JSON file into a data frame, the string R package, which is for manipulating huge strings that make up that text field we mentioned before, JSON-Lite, which is how we convert from JSON files or write to JSON files if need be, a text mining package called tidytext, ggplot for the data visualizations we're going to see later, and wordcloud for creating word clouds. Now let's talk about data preparation. In my case, I've got 4 steps for data preparation. The first one, of course, reading the data file itself. So we want to get that data file into R as an object that we can work from. In our case, we'll read the JSON files directly using the JSON-Lite package. It was very helpful for doing this. There's some other ways and other packages that you can use for JSON, but all I'm really doing is reading it in, converting it. So I don't need a lot of the JSON manipulation of some of the other packages. Initially, I thought I was going to be working with a CSV file and importing that. I used Python. I wrote a Python script that converts the JSON file to CSV. But in the end, it wasn't necessary for what I was doing. So we're just reading it straight in as a JSON file. Next, the unnecessary attributes are removed. For this analysis, I'm going to keep the unique identifiers, but we're going to get rid of the useful, cool, and funny fields. After this, the text itself needs to be cleaned. This involves removing stop words. Stop words are words that have no real bearing on things. They're the words that combine stuff. So at, the, us, those types of words are not necessary for this type of analysis, so we want to clean those out. Punctuation we don't need. We don't need any special characters. We don't need any new line characters, which you'll see in the JSON file. We also don't need any numbers. So all of those things would be removed, cleaned out of that big text blob. then that would lead you with a review that contains only whole words. And in some cases, you could remove word stems. I know in the previous class that we did sentiment analysis, we used another package which removes stems like ed and because sometimes that can create, those suffixes can double your word count. When you don't need them, you kind of remove it and then it becomes one word and the other one gets removed. But in this case, we're not going to do that. I didn't do any stemming for these words, and hopefully I didn't just ramble through that. Finally, we'll take those clean reviews, split the reviews by word into a scored collection of words. And the image that's there next to the progression of steps shows you my scored, or gives you a little bit of a screenshot of the scored list. So you've got the actual score from the review that the word came from. So in this case, girlfriend had a review score of 5. At least the review that it was found in had a review score of 5. So we gave it a 5. Now I know all of these are 5. That's just because in my R script, it organized them by review score. It's not all 5 reviews, 5-star reviews. Once we have our cleaned data set, we can begin to analyze the data. Over the next few slides, we'll take a look at the text that was extracted. For this preliminary analysis in this presentation, I only used the first 200,000 reviews within the dataset. Gave me a big enough dataset to work with, but didn't bog down my computer in trying to extract and analyze those words. The first diagram you see right here on this slide shows the top 100 words that are used within the dataset. If you're familiar with word clouds, I'm sure we all are. But in this case, you see the word and it's scaled based on the number of times it's found within the records that have been read. In this case, the word food is the biggest word, which makes sense. Yelp is definitely known for reviews of restaurants, whether they're fast food or fancy dining. So you would expect to see things like food and service, even delicious being a word that jumps right out at you. So I totally get why these words are like this. And then service is just a really important thing for not just restaurants, but also for any other type of business. You want them to have good service. So you expect to see these words a lot. Let's take a look at the review data. I could not work with the entire review dataset of 4.7 million records due to resource issues here on my workstation. I tried a variety of different ways to chunk the data and still be able to work with it in memory, and I just could not get that to work. So I decided to segment the data into something a little more usable, restricting the data size or restricting the data set down to the state of Arizona. So within that, that gave me a set of businesses of 47,376. The metric that is the most important to us are the review scores themselves. The following chart shows the breakdown of scores within our Arizona data. As you can see, the data set is skewed towards positive reviews. This was surprising to me as my perception of Yelp, where that they were typically negative, but that must just be the people that I follow on Yelp. As I mentioned before, or as we saw in the last slide, the data is pretty heavily skewed towards positive reviews. And one of the things we need to do is to create a binary classification. So what I did was I took the data that, or I should say all the star ratings, 4 and above, marked those reviews as positive, and then took the ratings that were marked 2 and below and marked them as negative. The scores of 3 were removed from the data set as they're considered neutral, and we're doing binary classification in this analysis. The chart itself that you're looking at shows the breakdown of positive to negative. So now that we have our words, our data segmented, 50-50 split, positive and negative, let's take a look at the words themselves. So when we started the data analysis section of this presentation, we took a look at a word cloud that showed the top words total in the data set we were looking at. Now we're looking at the top positive and negative words that are found within the reviews in the data set that we're going to be analyzing. So the two top, you can see, 2 word clouds, positive, negative ratings. One interesting thing, and I guess it really shouldn't be interesting, we saw before that food was the #1 word in the data set in total. So of course food would be seen in both positive and negative reviews. Um, in this analysis, a comparison of 2 classification algorithms will determine which technique to utilize in evaluating the Yelp user review score. The techniques that will be compared will be the naive Bayes and maximum entropy. The target value will be a derived value based on the review score. In this project, our 2 classes are positive and negative sentiment. The positive sentiment will be reviews with the score of 5 using the Yelp rating. Conversely, negative sentiment will consist of reviews with a score of 1. Pre-processing operations will be performed on the dataset to extract features. The diagram shows the process that this project will follow. We talked about it earlier, but we'll take our input text. We will extract the various features, which are the words, from the text. We will label them, run them through our algorithm to create our modifier. Then we'll take our test set, do the same thing, and then see how they compare to each other. And even sampling of positive and negative data from the Yelp review data set will be used to train our models. The naive Bayes classifier is a popular choice for classifying text data. While the technique is simple, because it makes assumptions on the data it interprets, it performs well as a classifier. For data sets where the problem classes have highly dependent features, naive Bayes is optimal. Alternatively, maximum entropy overcomes the problem that naive Bayes has with feature independence performing better where new words and phrases are encountered. Also, I'm adding, or I should say, there's a third technique, the least absolute shrinkage and selection operator, or lasso regression. This technique is something that I recently learned about. Like naive Bayes and maximum entropy, lasso is a linear model that keeps the good features of subset selection and ridge regression. I will be exploring this method using the GLM net package in R. Not sure if that's going to become part of the final project, but I am going to do some exploration of this particular package and see if it has any bearing or anything interesting to teach us. When I started this project, I thought that I would be using the least absolute shrinkage and selection operator, or lasso regression, as one of my machine learning tools. But as I began going through the analysis, and I made the decision to just look at to utilize the review score for the positive and negative rating instead of using a lexical database to give you the positive and negative for the words. Lasso regression works very well with a lexical setup as opposed to what I created on my own. So I decided to drop it because it really wasn't something that I was as familiar with as I want it to be. And so I didn't want to try and bang my head against. Now let's take a look at how our classifiers performed. First up is naive Bayes. And the chart that you see here visualizes the confusion matrix for this classifier. The red quads show where data was misclassified, while the green shows a correct classification. And so we started off with 670,000 records. And as I began to try and run this through R, I wasn't able to um, get the data, the vectors in memory in order to do the processing. So I had to keep reducing down the sample size of our data and finally settled in on around 4% of the 670,000 records, giving me a total of 26,908 observations. From that, I did a 70. For the next two classifiers, we split the data 50-50 for training testing. Maximum entropy performed very well with a 90% recall accuracy and a 9.7 misclassification rate. It performed. Finally, we have our support vector machine, which was, of course, like I mentioned before, kind of a last-minute addition when I removed the lasso regression. And it performed the best out of all three of the techniques used. The misclassification rate was 8.76, and with a recall accuracy of 92%. And as you can see from the graph, these are the three biggest lessons I've learned so far. Number one, while I thought my computer would be able to manage working with these large files, it took a really long time to do anything. Converting the files from JSON to CSV took several minutes. Attempting to build a corpus from the entire review set never finished, and in some cases would cause RStudio to crash. Number two, writing the JSON to CSV converter in Python gave me a headache. Python's not my favorite language, but at least I learned a little bit about it. The way the data sets are set up was not as straightforward as I would have liked. This made things fail in interesting ways. I had to leave the categories in the business JSON file as one string because it wouldn't separate properly. Ultimately, I didn't use that data set, so it doesn't really matter. But in the end, it was good to kind of beef up my Python skills. And the third one was just really over engineering. Like I had really grand ambitions on what I was going to do with this project, but the deeper I got into it, the bigger it got, and then ultimately I settled in on sentiment analysis, which is fine because my original goal with this assignment was not to pick something that I do at work every day. I work with a lot of very specific like numerical data and look for outliers and do confidence interval models and wavelet models on that data. But I wanted to make sure that I did something different. So doing sentiment analysis, working with text, which is highly subjective, was very different. And I've learned a ton working, or a ton so far.